The fifth industrial revolution started in the fall of 2022 when ChatGPT was released. Okay. That is, the fifth industrial revolution is about the convergence of human and artificial intelligence. That's what it is. So many people say fifth industrial revolution is about people. And I guess in an indirect way it is, but that's just a marketing thing. What's the technological advance? It's the ability to turn anyone into a data analyst.
Folks, if you've not heard about Walker Reynolds and you've not heard him speak before, you're in for a treat. Walker speaks often to various groups and has an excellent series of YouTube videos that explain Industry 4.0, digital transformation, and the industrial Internet of Things. These concepts and the technologies that enable them will empower present-day manufacturers, what Walker and other people call Industry 3.0, to be able to transition to Industry 4.0. Walker is the chairman of Intellic Integration and the president and solutions architect for his company 4.0 Solutions. His career spans 20 years with time spent in mining, steel, printing, and tier one automotive, and it has enabled him to transition into systems integration and ultimately become a businessman and an educator. Walker, I've heard your origin story, and I found it fascinating. Can you tell us about growing up and what influenced you to ultimately become a systems integrator, systems architect, and then to start your own company?
Great. Thank you. And I just realized while you're reading that bio that I've actually been doing this almost 25 years. I'm at 24 years this year.
You got to get Josh to change that.
Yeah, we're gonna have to get Josh to change that bio. But one of the, at IoT.University, we have this Discord server that most people ask, like, how do I get started with digital transformation? And, how do I start with my education? If Industry 4 starts with education, which is something I'll say a million times during this podcast, is where does my education need to start? And what we generally say is, well, what I would do is I would spend no money to start, like, go find all the free education you could find. And the best place to do that is to go to IoT.University/Discord and just join our Discord server. It's like 5,000, 6,000 people, a who's who in the industry, all in Industry 4, all across various expertise levels. But one of the most common question I get for someone who's in college, so say someone is in college as an engineer and they're trying to decide what to do with their career, or they've graduated, they've started in their first job and they're trying to figure out how they're going to make their name for themselves. And one of the most common questions I get is, how did you end up in this business? Like, if I wanted to, be like you, that is, I want to go on your career arc. How did you get to that career arc? And so I always have to explain, like, kind of how I ended up here, So I grew up in upstate New York in the 1980s. I was adopted. My mom died when I was young, and I got adopted by a family in upstate New York. I'm actually from Texas. I got adopted in 1982 in upstate New York. And for those of you who aren't familiar with the Northeastern United States in the 70s and the 80s, that was a transformative period in the Northeast. In the end of the heyday for Northeast manufacturing was the late 70s. So in the late 1970s in upstate New York, the economy was primarily manufacturing. And in the beginning of the 1990s, that was no longer the case. So, like, literally in just one decade, 79 to 89 or 80 to 90, most manufacturing in the Northeast evaporated. I mean, in just a 10-year period. And I watched my friends' families go from being middle class and upper middle class to literally working on farms. Like, they went from living in beautiful 2-story homes to living out in the trailer park with me, right? And if you look at upstate New York today, okay, I still own a home in upstate New York where I grew up. It is far worse than I could ever have thought it would get. Okay. The manufacturing leaving the Northeast, what devastated the Northeastern economy, absolutely devastated it. New York State today is a punchline. If we talk about New York State, it's always in a it's not in a good way. The average person doesn't talk about New York in a good way. But if you mention Texas or Tennessee or Florida, people are talking about those areas of the country as places with opportunity. Well, guess where that opportunity comes from? It comes from manufacturing in Tennessee, manufacturing in Texas, manufacturing in Florida, right? And there are economic factors, policy factors that drive that. So when I was growing up in upstate New York in the 80s, I just thought, oh, it was corporate greed that drove manufacturing out. It was all the normal narratives. Executives don't give a shit about their employees. They chase cheap labor, blah, 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 and they didn't care about the people that they left behind. I have since learned that that's just not the case. Most executives genuinely give a shit about the people they lead. I mean, genuinely, they really care about their people. And it is the rare executive who is totally dismissive of their responsibility to the people who work for their organization. That's a rare executive. I graduated in 1992, and while I was in college, I studied sociology. My plan was to teach. I didn't know what I wanted to do. I studied sociology, and while I took 2 employment courses in sociology in college, and I learned that my perception of what happened to manufacturing in the northeastern United States was not accurate. What had actually happened was when the third industrial revolution started, in 1969, the world's foremost manufacturer on the planet was the United States. We led the world in global production and manufacturing in 1969. 10 years later, who was the global leader in manufacturing in the world? Who was the global leader? Just a decade later.
Japan?
It was Japan. In 10 years. And what had happened? Why? Why did that take place? 1969 was the invention of the PLC. The first programmable logic controller came out in 1969. The things we take for granted, those little smart computers that automate our manufacturing processes all over the plant floor that we take for granted today, the very first one was introduced in 69. Well, guess which 2 nations adopted the PLC faster than any other nation? Japan was one of them, and Germany. The Japanese and the Germans adopted the automation of manufacturing faster than we did in the United States. And in fact, by 1979, 10 years later, the vast majority of manufacturing infrastructures were still relay logic. They were still hard physical relay logic. What happened was manufacturers started struggling to compete because the Japanese started producing more for less because they leaned into technology. What American companies did, was they offshored their labor to try and continue to compete while they figured out how to become digital. But they started 10 years late. What I realized was, if the industrial revolutions are natural evolutions of civilization, Industry 0 was the printing press, Industry 1 was the steam engine, Industry 2 was the assembly line, Industry 3 was PLCs, the automation of manufacturing process, Industry 4 was eventually going to happen. And it would almost certainly be the automation of business decisions. So if Industry 3 was the automation of the process itself, the equipment, Industry 4 would be the automation of the decision related to our manufacturing.
Okay.
In 1998, TCP/IP won the protocol wars. That was the transformative technology that started the fourth industrial revolution. Well, I happened to be in college at that time. In fact, I graduated in 1998. And so I got my first job out of college, was getting ready to go to grad school, and I worked in a salt mine that was using a combination of old technology and new technology. Guess what? American mining equipment called Fletcher and German mining equipment called SMAG. And I got to see with my own eyes that the American mining equipment made by Fletcher was hydraulic over hydraulic control. There was no electric control. There was no data acquisition. There was no automation. And then the German mining equipment, which was SMAG, was all PLC controlled. They were remote controlled. The operator would stand 30 feet away from that machine and run it with a remote, and it was all automated. They would literally push a start button, and it would do the entire roof bolting cycle, as opposed to a Fletcher machine where the guy was literally pulling all these hydraulic levers in a specific sequence in order to bolt the roof. And guess who could bolt more roofing? It was the one using the automated piece of equipment. I just saw it in front of me, right? Well, I also got introduced to automation accidentally. I won't even tell the story, but basically, while I was in college, I got a certification in 5-volt DC systems. The field wiring for the SMAG was 5-volt DC. I could also read German. So my supervisor sent me with an electrician to read the drawings for the electrician. And I sort of discovered I was an engineer there. So I went back to school and became a double E. I just said, oh my God, electrical engineering is where I should be. It shouldn't be sociology. I'm going to go become an engineer. And what I'm going to do is I'm going to help manufacturers take this technology in the United States, and we're going to transform the US economy. We're going to create and save middle-class jobs in manufacturing by helping manufacturers use this technology to become competitive, because the fourth industrial revolution had just started. No one jumped on. Hell, it took the Germans 15 years to define what they thought Industry 4 was. From when Industry 4 started to when they actually defined it was a 15-year period. Okay. Wow. Anyway, that's how I ended up in this industry. I charted a path and said, hey, I'm going to go learn as much about manufacturing as I can. So while I was doing my double E, I worked in the mine. As soon as I graduated, I switched and I went to printing. And then I spent 2 years in the printing industry. Then I switched and I went to the steel industry for 3 years. And then I switched and I went to tier 1 automotive. And that had given me an introduction into basically all manufacturing, how manufacturing works, what the problems are, what people are dealing with. At each of those 4 stops, I implemented a unified namespace infrastructure, an infrastructure upon which we solve the business's problems. And then after my last stop, I moved into systems integration. I worked for 2 integrators who were both world-class integrators on some huge projects. I won a major award on one of the projects I led, which sort of created my name in 2013. And ever since then, through my own companies, we've been scaling this implementation across the globe.
Wow. Quite an interesting ride. I know more of the detail of the story, but that was an excellent way to summarize where you've come from to get to where you are now. So when you talk about the industries that you've been in, those 4 different industries that you worked in, those were considered industry 3.0. Yep. And there was a technology stack that you talk about. Now, going into detail here will be difficult, but what was the thing about the stacks that they could not communicate well together?
Yeah, what became there's a if people want to understand the problem the industry 3 company faces. So what is an industry 3 company? An industry 3 company generally has very, very advanced technology at the ERP layer. So the automation stack is cloud at the very top, ERP directly below that. Directly below that is the manufacturing execution layer, MES, then supervisor control and data acquisition, then PLC HMI. An industry 3 company almost certainly is using a state-of-the-art technology at the ERP layer, is using state-of-the-art technology at the PLC HMI layer, but neither of them talk to one another. And the stuff in the middle generally is paper. They might have a digital SCADA system. They almost certainly have a paper manufacturing execution system. Industry 4 companies take all of those layers in the stack, they make them digital, and then they plug them together and have them interoperate through a common infrastructure, which we use the unified namespace architecture, which I created in mining. The industry 4 company is using data from all across the business, the digital events from all across the business. They're having software monitor those events, oftentimes machine learning, to find patterns in that data that we can't see with the naked eye. And from those patterns, it reveals problems we need to solve. If you look at, I asked the question, why is Amazon awesome? Why is Tesla awesome? It is amazing how few people know why Amazon is awesome. Like it's stunning. It's stunning if you ask people, why is Tesla awesome? How few people can answer the question. They know Tesla's worth a lot. They know they manufacture EVs, but if you ask them, why are they awesome? Why is it Tesla has been the only car manufacturer to a startup after the year 2000? Why is it that Tesla was able to beat the big car manufacturers, but no one else was. And the answer was because Tesla's not a car company. They're a data company. They use data to speed up what they learned in their business. So that if you were to look at the typical technology S curve, that is, as we're improving our processes. So if efficiency on the left-hand side, technology S curve, right? When we start continuous improvement, we generally see very low return in the beginning. It's almost a flat line. And then it kind of moves to a 45-degree angle and holds 45 degrees until we start seeing diminishing return on our continuous improvement investment. And then it flattens off, technology S curve. And then you would see some groundbreaking innovation. If you look at Tesla's technology S curve, so each industrial revolution, it has an S curve. If you look at Tesla's S curve for Industry 4, that line in the front where it's really flat, low return is very short. And the angle at which they improved was greater than a 45-degree angle. They were getting exponential return. And how were they doing that on their investment? How were they doing that? And the answer was, well, they weren't relying on data they couldn't trust, which is stuff human beings collects. They were relying on one common infrastructure and in digital data. That is, there's no smart thing in their business that can't access the data it needs to get smarter. That's the best way to put it. Think about, you go in the average manufacturer and we ask operators, we ask supervisor, we ask managers, we ask directors, we ask executives, what is the biggest problem you have? And they will say, getting access to the data I need to make decisions. Putting it in, just having visibility. You know, the number of supervisors who have to walk around on the plant floor and just to check and see how operations are going. To talk to the operators, how's the machine running today? That isn't how Tesla operates. That isn't how Amazon operates. How does Amazon deliver to you anything you want in 99% of the time in 48 hours or less? They predict what you're going to buy 6 weeks before you buy it. And when I ask people, how does Amazon predict what you're going to buy? You get blank stares. The answer is digital data. They collect every single event, from weather information. When did a truck leave a distribution warehouse? When did it get to the end of the parking lot? What was the total number of fuel stops on route to the next distribution center? To your browsing habits in your local web browser. They combine it all together to predict what you're going to buy and how to get it to you in 48 hours or less once you buy it. That's digital.
Yeah. Well, and that's the definition of the digital factory, right? Is the fact that you have this unified namespace, UNS, right? This is your abbreviation for that. Unified namespace allows you to be able to pull the information out of all these discrete technology stacks of the industry 3.0 that we've been living in all this time.
Right.
So now you're able to pull all that stuff in and do analysis. I guess big data is the other defining element of industry 4.0 and digital factory.
Yes. Wow. Yeah. So when you think about what unified namespace is, I try to describe it as it's an architecture. Okay. But it's an architecture on technology that meets some basic minimum requirements. So number one, whatever technology we're using must be edge driven. So if I plug, me, you, Ed, Josh, Christy, our producers, if we plug the four of us into a common infrastructure, and what we want to do is communicate with one another. Unified namespace is an architecture where I give Walker a place to put his data and information. I give Ed a place. I give Josh a place. I give Christy a place. And then we agree on some rules. Ed, if you got something you want to communicate to the rest of us, you're going to publish it to your place. And if I want to be informed about that specific piece of information, I'll subscribe to it. I will. So every time you update the thing that you want to inform our ecosystem of, I'm going to be notified of the change. Okay, that's called edge-driven technology. Also, report by exception. So the smart thing in the business is reporting in. We're not polling it for its updates. That's one of the fundamental differences between an industry 3 company, industry 4 company, is an industry 3 company is comfortable with poll response architecture, which, by the way, doesn't scale. We cannot pull enough data by polling, because when we poll, most of the time, if I want to, if I wanted to get updated of Ed's data and I'm the server and Ed's the client, and every 1 second I'm saying, hey, Ed, any changes? Ed, any changes? Ed, any changes? And every single time you respond with no, 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 no. Yes, the small one. No, no, no. Think about all that overhead, all that wasted communication on the line. Edge driven is we're connected together and I can trust that when something changes, you'll let me know. And then that one time you go, hey, Walker, that report's done. And now I get notified. That's edge driven report by exception. Industry 4 companies use technology like that to build their infrastructure. And then we use a unified namespace, which is essentially the rules for where data and information goes. So that all I have to do is teach you where it is. That is, here's where our infrastructure is, and here's how we organize stuff. And no matter what you're looking for, you'll be able to find it. You don't have to explicitly know that there's a temperature sensor on the bath that goes into on the infeed of our cell. You know where to go and look how the cell is constructed and see which sensors are where on the machine.
Wow. Does this become what you call the single source of truth?
Correct. Single source of truth. There's an important thing here. Single source of truth is the structure and the events of an organization. Single source of truth is when I look at my infrastructure, I am looking at the current state right now. This temperature sensor and the OEE calculation are both current. Okay. Or the batch ID, the work order ID, which are coming from different systems, the temperature sensor and the OEE calculation, which is coming from MES, are current. I know I'm looking at current state. That's single source of truth. You may have systems of ownership that are separate from the single source of truth. The single source of truth is the structure and the events. But I may have, let's say I'm into ISO 55001 compliance, and my system of ownership is going to be the database that stores each of the compliance records for ISO 55001. And maybe that record is generated every 60 seconds. Well, the single source of truth is the place where you're going to retrieve that record and store it in the system of ownership, right? So that's the important thing, is that a unified namespace architecture is current state. It's right now. And then you will have nodes that store history. They will subscribe to the things that need to be stored and store them as they change.
Wow. So you talk about, we collect all this data in our companies now as they become industry 4.0 and digital factories and whatnot. But you make a distinction between the data that we collect and the information that it becomes. What is that distinction?
So it's very important. People misuse the term data. All right. So important distinction between data and information is you cannot take action on data. You cannot make a decision from a data point. Okay. You have to turn data into information. You have to inform so that I can make a decision about how I want to adjust. So let's say a really good example would be, let's say I've got a mixing application. So I have a mixer with an agitator, and I have a temperature sensor. So I know the speed of my motor. I know the vibration in the mixer. I know how long it's been mixing. And I'm also measuring the temperature of the fluid inside the batch. And let's say we know if the temperature of that fluid exceeds a certain temperature, then we'll have to take some type of action. Okay. All right. The data point would be 50 times per second. We are reading a temperature off of a thermocouple, off of a thermocouple. And that's oftentimes going to come in a raw format. It's going to come in as a 4 to 20 milliamp signal into an input card. Okay. And then we're going to scale it and into Fahrenheit. And then we're going to store it 50 times a second in a historian. Just by looking at the temperature in Fahrenheit, what it was the last 50th of a second, okay, the last 50 hertz is meaningless to me. I can't, just because the temperature is high doesn't mean I could take action on it, because if transition 48, the temperature was 70, transition 49, the temperature was 155 Fahrenheit, transition 50, it was 70. If I look at the three data points together, I know to throw the 155 away. It's an anomaly. Okay. It's an anomaly coming from the card. You can never take action on one event. That's not data. Data,
That's not information.
That's not information. You have to convert data into information. Once I'm looking at a data point over 3 transitions, now I have information because there's a relationship between the 3. I can be informed about something. So very, very important to understand that information is what we take action on, and data is just an event, something that happened and when. Okay.
Something happened and when. Excellent.
Something that happened and when. That's it. That's all data is.
No
and information is the stuff we convert data into. Either I can take one data point and convert it into information, or I can take the relationship between many data points and convert it into information, something I can take action on.
Wow. Awesome. Now, when you define the industrial stack, you were talking about the top layers are IT focus or IT's realm, if you will, and then below that was the OT, the operational technology folks, right now. And now you're talking about combining those. That's what the UNS does, is because you're able to see all these different layers in the industry. Do the 5 layers that you define as Industry 3.0 go away eventually with Industry 4.0?
So the answer is sort of. So in practice, the stack flattens, on one infrastructure. But in the reality is that what we see, let's say I combine OT and IT infrastructure together. I go one common infrastructure. What happens to the OT people? What happens to the IT people? Well, the answer is, well, nothing. They both stay there, except now they have access to the other domain's data. So like if I'm an IT person and you ask them, in theory, IT's job is to provide value for the business, and our business is a manufacturer, and the thing that we do is we make stuff on the plant floor. If OT and IT are diverged, which they are 99% of the time, and there's reasons for that, then IT doesn't have visibility into the data they need to help the business improve, because the business happens on the plant floor. It doesn't happen in ERP. It doesn't happen in any of the IT infrastructure. The business is happening on the plant floor. And anyone who thinks otherwise in a manufacturing environment is a fool. I mean, we are in the business. If you've worked on the plant floor, you know what is king. Everyone knows what king is. It's production. Okay. That's where all rules go out the window. Literally every rule, every policy, every procedure goes out the window in favor of production when the rubber really meets the road. Now, no one's going to say this publicly. No executive is going to come on here and go, yeah, you're right. What we mean is we want to be safe as long as we're producing. But if we got to choose between producing and being safe, I hate to break the news to you, we're picking producing. And by the way, every manufacturer picks producing. There's nobody who's going to come on here and tell you that manufacturers, when the rubber really meets the road, they choose safety. Because I've been doing this long enough to see it with my own eyes. Even the safest companies in the world, Cargill, for example, which is considered one of the gold standard in safety in industry. Cargill, which is a privately held multinational. Even Cargill chooses production over safety when the rubber really meets the road. They never consciously say we're going to put our workers at risk. What they say is we don't believe they're at risk, therefore we can focus on production, right? But the end of the day is the business happens on the plant floor. And so your digital infrastructure should reflect that. Right now, when OT and IT are diverged, just by virtue of the fact that IT isn't connected to the OT infrastructure, and OT is not connected to the IT infrastructure except through a switch where they might do network address translation or through some type of DMZ from the Purdue security stack. That means that you have people in OT who don't have access to the data they need to create the information to take action on. And the same holds true for the IT group. So you still end up with IT and OT domains, job functions, but they're all operating on a common infrastructure. They have access to the data they need. But does PLC HMI layer go away? No. Think of it more as, instead of the data moving up and down the stack, the data moves left and right into a common infrastructure. Think of it that way.
Awesome. So the leadership that requires companies, that the leadership that needs vision to be able to move from industry 3.0 to 4.0. What kind of leaders do you call those? Are those transformational and transitional leaders?
So there's transformative and disruptive. So go back to the technology S curve, right? So the technology S curve is also known as the continuous improvement S curve, right? So when after we have made in 1969, or let's go to 79. In 1979, when wide adoption of programmable logic controllers, PLCs, that technology that came out in 1969, when we started seeing wide adoption in the United States, there was a period of about 10 years where manufacturers were going bankrupt, they were getting acquired, or they were transforming. There were one of three things was happening. Okay. During that 10-year period, while they were upgrading infrastructure, they were sort of in a continuous improvement holding pattern, right? It was sort of like we're doing groundbreaking innovation, we're kind of feeling it out, and then we'll start continuous improvement back up. The beginning of our technology S curve. After that, transformation. The people you need in that 10-year window, that 15-year window while you're transforming, are different than the people you need when you're leading continuous improvement. So one of the biggest challenges that executives have, and here's the difference. You want technologists to lead you during the groundbreaking innovation, and you want MBAs and accountants and bean counters to lead you while you're doing continuous improvement. Because so much of what you're doing is risk assessment. So much of it's ROI calculations. When you're innovating, there's no data for you to calculate ROI on. So any ROI calculation that an innovator gives you is just something pulled out of the, they pulled it out of the ether. Okay.
Air. Let's say air.
Okay. It's pulled out of there. It's a different type of leader. Right now, if you look at Amazon, you look at Tesla, you look at Volkswagen, like who are they led by? Volkswagen is way ahead of the curve relative to other manufacturers in digital. They're all led by technologists, engineers who have stayed highly digitally fluent in bleeding edge technology. Mm. It's no secret that Elon Musk built the transformative digital payment platform first. Okay. Then he goes and he builds the first EV company that can actually compete against the major players. Then he goes and does SpaceX. He does the Boring Company. He's drilling tunnels under LA, and then he's doing Neuralink. It's no secret that he's not getting lucky. Okay. No one gets lucky like that. Okay. The reality is that he is a technologist who sees where bleeding edge technology fits in humanity's future, right? He's a transformative leader. Whatever you believe in his politics or whatever, doesn't change the fact that he's a transformative leader, a disruptive leader. I just read a story I shared with my kids this morning. Elon was in a meeting. It was a story from Walter Isaacson's book. And Isaacson was in this meeting, and he asked a question called the Idiot Index. I don't know if you guys know, Elon has a term called the Idiot Index.
Oh, I haven't seen it yet.
All right. So the Idiot Index it's really designed for him to determine whether they should make the part or they should buy it from a vendor. And so what they do is they calculate the multiplier between the cost of the raw materials and the cost of the good that they get from the supplier. So if it's like 10 to 1 or greater, that is the raw materials cost 10 times less than what we're paying for this thing from our vendor, the idiot index is too high and we need to manufacture it ourselves. Okay. All right. So Elon asks one of his finance guys, what is I think this is at SpaceX actually. He's looking at something on the rocket and he says, what are the parts on this rocket that have the highest idiot index? And the finance guy that he's talking to says, I don't know. And Elon says, you need to know that off the top of your head. And if you want to work here, next time I ask you the idiot index and you can't give me the answer, I'll expect you to submit your letter of resignation. Okay, that's what he said.
Wow.
Okay. Walter Isaacson asked him, don't you think you were a little harsh on this guy? Elon said, no, I wasn't too harsh on this guy because physics doesn't care about your feelings, doesn't care about the hard things you're going through. Physics cares about, is the rocket built correctly? That's it. And what type of leader is that? That's disruptive. Okay. A disruptive leader is the leader who will tell you the thing you don't want to hear because they're right. Okay. Now think about this. Think about the number of manufacturers you work with, Ed, that you've talked to. How many manufacturers that are legacy manufacturers would a leader say what Elon said to that guy? And the answer is none. There, right? He gave a 0 here on the camera. The answer is basically none. Why? Because their thinking is, there's nothing to disrupt here. Don't upset the apple cart.
Yeah.
A disruptive leader is thinking, all we're going to do is upset the apple cart, because we have to change the direct attack of the ship. We have to change the way people think. We got to change the way people approach solving problems. And what Elon was telling that bean counter was, you can't do your job unless you know the idiot index on every single part in that component.
Wow.
That's a new way of thinking. That's disruptive.
Very interesting insight. Yeah, awesome. So let's kind of wrap up here. What would be your advice to someone that's wanting to get involved in the transition of Industry 3.0 to 4.0, the digital factory, and does artificial intelligence and ChatGPT and those emerging technologies, exponential technologies that are being brought into the marketplace, are they going to be applied to Industry 4.0, or does that become Industry 5.0?
So the answer is, I'll answer the last question first. So the fifth industrial revolution has started, but just like when the fourth industrial revolution started in 1998, when TCP/IP won the protocol wars, we didn't really know that the fourth industrial revolution started until about 2001. So we were able to look back on 98 and go, oh, wow, that's what changed everything. When you started seeing like KEP server coming out in the early 2000s, KEP servers coming out with drivers that are allowing us to take the data from all of our PLCs and stuff on the plant floor and our flow meters and getting that stuff into an IT infrastructure without having to bring it over a field bus like Data Highway Plus. Like, without us having to run blue hose into the data center, we're able to do this over, Ethernet protocol. Okay. But we had to look back on that. In 2001, we're kind of like, oh shit, the fourth industrial revolution started in 98. It's the same thing now. The fifth industrial revolution started in the fall of 2022 when ChatGPT was released. Okay. That is, the fifth industrial revolution is about the convergence of human and artificial intelligence. That's what it is. So many people say fifth industrial revolution is about people. And I guess in an indirect way it is, but that's just a marketing thing. What's the technological advance? It's the ability to turn anyone into a data analyst. I mean, literally, you can take just raw data, throw it into a large language model or large language learning model, and you can ask a chatbot to analyze the data on your behalf. Give me our production for this product code on Wednesday mornings between 9 a.m. and noon, when one of these three operators are running the piece of equipment, and order it in the order of highest performer to lowest performer. You can now do that using chatbots, as opposed to days and weeks of people sitting in an Excel spreadsheet trying to generate that pivot for you, right? So is AI used in Industry 4? Yes. But the bulk of artificial intelligence will be what we refer to as Industry 5. A good example of where AI is used in Industry 4 would be something like, I'm using artificial intelligence to do like sophisticated statistical process control, where I'm looking at a series of variables. So instead of one process variable, I'm looking at 5 or 6 process variables to output to a single control variable to, say, adjust the speed of a mixer, right? I'm looking at many variables. I'm using artificial intelligence I'm using ML to learn from that data, but I'm using artificial intelligence to recommend an operational adjustment. That's an industry 4 application. Industry 5 application is all the other stuff we think of with AI. Okay. And then where do you start? Well, I would say this. Number one, understand what digital transformation like in practice actually is. So for a manufacturer, digital transformation is a strategy. It's here's why we want to be digital. But when you are working with them to help them digitally transform, you are basically working in one of 3 domains. Okay. Domain number 1 is connecting to all the data, collecting it, and storing it.
Right.
So that could be across PLCs, databases, you name it. Domain number 2 is analyzing that data and visualizing it, either in reports or screens. And then the third domain is the ML AI domain, find patterns, predict, report, and solve on that data. Okay. If you know that you're going to be working in one or more of those 3 domains in digital transformation, then the next place is to whittle down where you think you might fit. And the best place to do that is to go to IoT.university, join our Discord server, or take our free IoT mini course and just get like the lay of the land and talk to people. Like just talk to people in the industry about what digital transformation actually is. Because if you were to Google it, you're going to get something different than what it actually is. And the best place to do that is in our industry 4 community.
Something that's verifiable and trustworthy, right?
Correct. And you know, there's no one is, you know, if you go to our Discord server, it is literally, you know, thousands of professionals all talking about their applications and problems they're running into, what works, what doesn't work, new use cases that no one's even considered. You know, that's the place to do it. And there's a lot there. There's a lot there. I mean, there's, you know, millions of messages. I think we're well over millions now. Wow. There's a lot there, but everything's organized by channel. And, you know, I'd go to the digital transformation channel and I'd just start reading the thread.
Awesome. Awesome. Well, I got started watching your videos. So you started off, what, 5 or 6 years ago? They tricked you into doing a presentation, right?
Yeah, 2018, Zach. So Zach started a media company. He's an engineer I had worked with. We've remained close friends since 2012, 13. He started a media company and asked me to sponsor his podcast. And that's how, and I said, sure. I wanted to help him out. So then after the podcast, I was like, why don't I hire you to do digital media for us? But the deal is I will not be on camera. So you're going to build a YouTube channel for us, but I'm not going to be on camera. And for the first 6 months, it didn't really work. Nobody really watched anything because we didn't figure out we didn't really know what we were doing. And then Zach tricked me. He believed that we needed to be doing education. And so he set up a camera in front of a whiteboard and he called me out and he said, hey, my video editor doesn't know anything about what we do. So I'm going to ask you a couple of questions. You're going to answer the questions and I'm going to send him the video so that he knows what it is we actually do. And that's that first series. What is IoT? What is Industry 4? It's the stuff we're reshooting now. That's why I'm not wearing a mic. It's all, you know, what happened was Zach took one of the videos, he published it to LinkedIn and it went viral. It got like 100,000 views in like 3 days. And then he did this Industry 4 rant video. He had me do a rant and I complained about ERP is not the center of the universe. And that was kind of our big on YouTube. That was our big viral YouTube video. And ever since then we've been, yeah, I think we just broke 600 videos on YouTube. So
was that right? That many?
Yeah,
I'm only a fraction through them then.
Yeah.
But they're all, so they're not only entertaining and educational, but they can get very deep on some of those topics that you got involved in. So just FYI, for folks that are trying to get an understanding of what's going on here, that's a great place to get started, to see your videos on your YouTube channel, and then go to the Discord server, right?
Yep. And so the YouTube channel is 4.0 solutions. So the number 4.0 solutions, that YouTube channel, we have a bunch of playlists there that, I mean, all that education it's all the foundational stuff. Most of the time it's, you know, I try not to get too technical on the YouTube channel because we see that if we do a technical video, it generally underperforms and it can kind of mess the algorithm up. And then we get way more technical at IoT.university because we know who we're talking to.
Okay, that makes sense.
We know that they're engineers. We know, right? And so there's a mechanism So you know whether or not to take the next step if you are craving more technical content. That's basically how it works, right?
Excellent. Perfect way to explain it then.
Yeah.
That makes sense. Absolutely. So just kind of wrapping up here, you're going to be speaking again at my IoT happy hour. You've spoken twice before, and we kind of agreed that you'll come back and update us every 6 to 9 months or whatnot. I think it's been about 7 months now since the last time you spoke.
Yep.
So for those folks that can make it, hopefully we'll produce this video and podcast before your event. You're going to be speaking on April the 4th at the Spring Hill Suites here in North Dallas. So for people to get details about the meeting and the time and your topic, you're going to be sending me an abstract here shortly about what you're going to talk about. Our viewers can go to Google search IoT Texas Meetup, IoT Texas Meetup, and it'll bring up the Meetup site for IoT Texas. And all the information out there will be about this meeting and then future meetings as well. I do one every month now for IoT Happy Hour. So we're looking forward to having you come and present to us at that point.
And I will be going for that presentation. I'm actually going to be going through a unified namespace.
Awesome.
So we're going to be plugged into an infrastructure, and I'm actually going to go through and I'm going to tell some stories around it.
Awesome. You're a great storyteller. So not only are you very informative, but you're entertaining as well. So I always appreciate you're like my wife. You're able to keep people engaged and then kind of give them a little twist at the end as to something very special has happened, whatnot. So looking forward to that.
Thank you.
So
we've gotten great feedback from those sessions.
Any other words of advice or how you'd like to end the meeting, the conversation here?
Well, I would say this, you know, I spoke last week at the PMI chapter for Dallas at their annual dinner. And one of the things that I was surprised in that session, nearly everybody in the audience, was 130 something. Nearly everyone in that audience was a project manager. And when I asked who here is using ChatGPT in their job function, like all day, every day, the number of hands went up were insignificant. I was really shocked. So what I want to leave with is this. Here's how has our world changed since ChatGPT, Gemini, all those tools have come out. Here's a recommendation. You should be working with tools like ChatGPT all day, every day. You need to think of yourself as a AI supervisor. Okay. You should have a screen open. You should have two desktops, one that's open to just your AI chatbot. Okay. And you're supervising AI all day long. That needs to be your mindset. Okay. And number two, you need to be using all of the chatbot tools. So you need to be using ChatGPT. You need to be using Gemini. You need to be using Grok, right? You need to be using all the tools to just work on your digital fluency around artificial intelligence and prompt engineering. I was never even going to mention that here, but if there was one thing I could encourage people to be doing, just one, it's that. It's you need to be working on your digital fluency with AI chatbots. Okay, because it's going to take you a year and a half to get up to speed. So you may not even be using the tool every single day for another year and a half, but it's going to take you that long to gain your fluency.
Wow. Great insight there. My producer is praising your words because she's been trying to push me to get more involved with ChatGPT. So thank you for doing that.
Awesome.
So for our viewers, if you would like to see these presentations and other people, the North Dallas area has a tremendous amount of talent and incredible technologists, business executives, and entrepreneurs here in the North Dallas area. Walker is one great example of that. But if you'd like to be a part of our meetings, come see us. Go to IoT Texas Meetup, or if you like to, I record a lot of our sessions. So I have for the last 5 or 6 years now. So if you'd like to see some of those videos, on my YouTube channel, go to YouTube, do a search for IoT and Beyond, IoT A&D Beyond, 3 words, and you'll come to my site and you'll see Walker speaking. We're going to recording him next on the 4th, and so he'll be out there shortly thereafter. This presentation will be there as well as others. So Walker, thank you very much. It's been very enlightening and fun to hear you talk and give us your background and tell us about what's coming.
Awesome. I appreciate you, Ed. And I'm look forward to seeing you again in April.
All right, man. See you then. Take care.
Okay. Thanks.
Bye-bye.